Your 40 GHz link budget's off. Insertion loss is way higher than you simulated. It might not be the dielectric. It might be the copper. A lot of designers coming from 5 or 10 GHz assume thicker copper means lower loss. At millimeter wave, that intuition is wrong. Today I'm showing you how to actually choose copper thickness and foil type so your design doesn't significantly degrade your link budget. Here's what trips people up. At 40 GHz, current doesn't use the whole cross-section of the trace. It crowds into a thin layer at the surface. That layer is the skin depth. In copper, at 40 GHz, it's about 0.33 microns. So 0.5 ounce copper is already 17 microns thick. That's 50 times the skin depth. Roughly 95% of the current flows in the first 3 skin depths, about 1 micron. The other 16 microns contribute very little to reducing RF loss. Going to 1 ounce or 2 ounce does very little for RF loss. The current barely benefits from that extra metal. What it does do is make your life harder. Thicker copper means wider minimum traces for the same impedance, worse etch control, and worse impedance tolerance. With 1 ounce, the etch taper is worse. You get a more pronounced trapezoid, wider at the base than the top, so the cross-section isn't a rectangle, and impedance modeling gets messy at 40 GHz. At 40 GHz, your microstrip might be 6 to 8 mils wide on a thin substrate. You want that etch to be precise. So for 40 GHz signal layers, thinner copper wins, 0.5 ounce or 0.25 ounce where your fab supports it. The main thing driving your loss at 40 GHz isn't thickness, it's surface roughness at the substrate copper interface. Rougher copper means a longer effective path and more loss. Smooth copper means lower insertion loss and more predictable phase. So you need the right foil type, not just the right weight. 2 main families, electrodeposited or ED and rolled. ED is plated onto a drum. The side that touched the drum is smoother. The treated side, the one with the nodules or teeth that grip the resin, is rougher. The current has to follow those peaks and valleys, so you get extra path length and more loss. For outer layer microstrip, the drum side typically faces air after etching, and the treated side is against the core. But the critical interface for loss is the copper dielectric boundary, so you want smooth foil on that side. For strip line, both sides matter, so you want smooth on both. The cleanest fix is to specify HVLP or VLSP, smooth enough on the bond side that you don't have to worry about orientation. Rolled copper is the smoothest, typically 0.3 to 0.4 microns RMS on the interface. At 40 GHz, roughness can increase conductor loss by 20 to 50%, so specify smooth foil, rolled or ED with HVLP or VLSP. If you don't specify, many fabs will ship standard ED. Your measured loss can end up half a dib per inch higher than your sim. Ask your laminate supplier for RQ or SAI at the bond side, or Huray or snowball parameters if you're in HFSS or ADS, and plug that into your EM model. For power planes, you can still use 1 ounce if you need current capacity. For RF signal layers at 40 GHz, stick to 0.5 ounce smooth foil, and use thermal vias if you're doing high power RF or PA design. We're focusing on conductor loss here, but at 40 GHz, dielectric loss matters too. Make sure you're also using a low-loss laminate like Rogers or Megtron. So here's the workflow for 40 GHz. 4 steps. Step 1, thickness. For 40 GHz signal layers, use 0.5 ounce or 0.25 ounce if available. Don't go 1 ounce or 2 ounce on RF traces. It hurts etch and impedance and rarely reduces loss. Step 2, foil type. Specify smooth, rolled, or ED with HVLP or VLSP, and confirm which side is against the dielectric. Get RQ or SAI or Huray parameters for that interface for your sim. Step 3, model it. In your EM tool, enable a conductor roughness model, RMS, SAI, or Huray or Snowball, and plug in the foil data. Otherwise, you'll underestimate loss and phase shift, and your link budget will be wrong. Step 4, talk to your fab. Not every shop has 0.5 ounce smooth foil on the shelf. Ask for 0.5 ounce HVLP or rolled 0.5 ounce for outer signal layers. Inner layers can be 0.5 to 1 ounce depending on current. The PCB stack-up generator tool recommends 0.5 ounce HVLP across the board for best etch precision and impedance control. Use that as your baseline and only thicken where you need DC or thermal margin with thermal vias. The takeaway is at 40 GHz, thin and smooth beats thick and rough. Pick 0.5 ounce, pick smooth foil, and model roughness, then your link budget will match the board. Check the show notes for the PCB stack-up generator tool to get the right copper recommendation for your frequency. Now, go build something that actually works at 40 gig.